Hello everyone, welcome back to Explore Electronics. In this video, let's see the question paper of VTU exam for the subject Digital System Design using Verilog, the exam on February 2023. Let us get into the question paper and let us see the questions appeared from each and every module. So here at the top I have syllabus copy of DSDV. Below you can see the question paper of VTU examination. Let us go module wise. Let me take the syllabus of module 1 first. Module 1 is principles of combinational logic. Here in the question paper you can see the question on what is combinational logic. Give example, explain combinational circuit with block diagram. So it is a theory question they have asked on combinational circuit. Then define canonical form representation and solve the equation using canonical form. So the two expressions or functions are given for 8 marks. Then simplify the Boolean function using K-map question is given. This is the question 1 from module 1. We have a choice question for that. In the choice question you can see again K-map question is there for 4 variable K-map, and Quine-Maklowski method using that you need to solve the Boolean expression. So the function is given here. So this is from module 1. So you can expect easily one K-map question for sure. It is 3 variable or 4 variable question, and another question will be Quine-Maklowski method minimization, and some question will be from canonical forms and generation of switching expressions or combinational circuit. So combinational circuit definition examples are very important here, and you need to solve K-map and Quine-Maklowski method so that easily you can get 20 marks over here if you know K-map and Quine-Maklowski method and combinational circuits. Coming to module 2, module 2 is logic design with MSI components and programmable logic device. Here binary adders, comparators, decoder, encoder, mux and PLDs are the content of module 2. If you see the question paper, binary adders with K-map and logical expression of equations for sum and carry is asked. So full adder can be explained here, and then carry look ahead adder also asked here in 3B, and 3C is decimal adder. Means if you learn all the adders like from the half adder till carry look ahead adder and BCD adder, decimal adder, you can answer this question easily. Similarly, the choice question if you see comparator circuit and 2-bit comparator, magnitude comparator is asked. So a 2-bit comparator is a simple one. It is asked for 8 marks. You can easily score. And using 3 to 8 decoder and mux, there is an implementation question in 4B and 4C. You can easily expect this question in examination. Out of mux implementation or 3 to 8 decoder implementation, out of these two means choice questions, you need to answer at least one. It will be like that. But in this question paper, only in the 4th question they have added decoder implementation and mux. It would be added on the 3rd question also, and one adder will be added over here. So one adder and as well as one implementation using decoder or mux will be mandatory here, and you can expect easily. Coming to module 3, what is module 3? Module 3 is flip-flops and its applications. So what are flip-flops? Master slave flip-flop, and then JK SR flip-flops are very important, repeatedly asked in many times in other subjects also. So flip-flops and truth table characteristic equation is must and should, you need to know. The question will be there on that. And then comes registers, binary counters. So here you can see JK flip-flop, edge trigger flip-flop, master slaves JK and SR flip-flop completes the question number 5 here. But in question number 6, that is the choice question of this module, comes counter and registers. You can see counter as well as different registers like serial in parallel out, parallel in serial out, and parallel in parallel out. Such questions will be asked. And the mod 6 counter design. And again, counter design is a very important question. You may get one question on counter design. Directly they may ask to implement synchronous 4-bit up counter or down counter, something like that, or they may give the sequence like this and to implement. So the one question will be there on counter, and flip-flop explain JK SR flip-flop will be there as important. and master slave also important. So one question you can expect on counter as well as one question on flip flop, and one more question they can add like this, like edge trigger flip flop, what are registers, like that. So this is also an easy scoring module, you can easily score. Coming to module 4, it is introduction to Verilog and data flow description. So here what is HDL, like define HDL and types of HDL. You should answer like what is the structure of a Verilog module, how it will look like, VHDL and Verilog, bit difference between those two, and data flow description question, like writing a Verilog code is very much important. So write a note on data types of Verilog is asked, logical operators is asked, and 8:1 is asked. So you need to know all the operators of Verilog and which are all the data types, and then Verilog code for 8:1 mux. So this is what question number 7 is. Coming to question number 8, that is the choice question. Here different styles of description of Verilog with an example you need to write. So try to practice at least 1 or 2 codes like full adder or half adder, encoder, mux, like that. For all the 3 descriptions, you need to practice writing the code in gate level as well as data flow as well as behavioral style. Then it will be helpful to answer many questions in the question paper. Then write Verilog code for full adder. It is also very important, every time you will get this question. Then write a note on arithmetic shift, rotational shift, and relational operators. So one question will be there on operators or data types, like that, and one question will be to write the Verilog code itself. Then coming to module 5, it is behavioral description and structural description. So in behavioral description, signal assignment they have asked, structure of behavioral description they have asked, sequential statements. So here behavioral description, in the sense, again always block, if else statement, case statements will be very important. They may ask to write the syntax of those, or they will be asked to write complete code using case statement, or give an example code using if else statement, something like that. Questions will be appeared in exam. Here also if you see the choice question, 2:1 mux using if else statement is asked, structural description with example is asked. For this, better to go with full adder design using 2 half adders, where 2 half adders become the structure where the construction of the full adder. So practice these Verilog codes starting from half adder to up to structural description of like ripple carry adder. It will be very good. Mux, demux, encoder, decoder, everything, at least some 10 to 12 Verilog codes if you practice, then it will be easy to write the questions in the exam. So the answers should be consisting of the truth table always, expressions if it is needed, a block diagram, and then Verilog code. Similarly, if you come to the first 3 modules where the simplification and all there also you need to write the block diagram wherever it is necessary. You need to write the logical expressions as well as the circuit, gate level circuit. This is about the 5 modules of DSDV. In my playlist, I have also given some important questions of this complete syllabus. You can go through that. That will be helpful in preparation of examination. The complete solution of this question paper I will be uploaded in the other video. You can go through that and find the answers, how you need to write it in exam. It will give you the split up of marks also. Thank you.